This is an introduction to microcontrollers. What we're going to be looking at this session is in terms of the basics of microcontrollers, how they function. We're going to be looking at programming them using CH, and we will then also be looking at a small demonstration of different things connected to the microcontrollers and then see how they operate. So for us to start, let's start off with just a basic structure of a microcontroller. So essentially over here, it's a microcontroller. It's a chip or integrated circuit or an IC. It's got a whole bunch of little legs coming off from it. And in the past, whenever we had to develop some electronic circuitry, we would only be issued with these chips, and then we had to essentially connect a whole bunch of things to it. There would be a whole bunch of other circuitry that would be on the boards that we would have to solder onto it, and there would be like voltage regulators, there would be maybe some filtering capacitors, and all these type of things we had to then build onto these boards to make it possible to program them, as well as to let them do certain tasks. Yet fortunately for the newer generation, there are these Arduino boards. So the Arduino boards has got essentially the chips or the ICs for the microcontrollers soldered onto them. It's got a whole bunch of electronics that are included. There might be a programming chip on it. There might be some other electronics that are not shown in this specific diagram. And then it allows you to actually take this board, program it, and use it as needed. So essentially what has happened is all these pins that are on this microcontroller are essentially mapped out to these different header pins that are on the side of the board. So it's easier to connect to them. You don't need to solder or anything. You just plug in your pin to the respective point over here, and then you can use it. Okay, so the Arduino boards, they come in different sizes, they come in different capabilities, but essentially they are all of a similar structure. I've got a very similar pin layout. These Arduino boards are using the Atmega chips from Atmel, and so the Atmel chip series have got very similarities. So you are able to essentially whatever you do for the Arduino Uno, as what we're looking at over here, you're able to use it, very similar principles and techniques, and essentially the same code for the Arduino Mega boards or the other boards that might be out there. Okay, so let's just have a look at quickly at the layout of these boards and what it consists of. So usually there's the external power supply. Now you will see that the USB plug that's on these boards actually allow you to program the microcontroller as well as power up the microcontroller. So it powers up from your computer's specific port. Yet these ports are very limited in terms of the amount of current that you can draw from it, and so you don't want to draw too much current and then cause specific USB port on a computer to blow, and then you can't use that anymore. So for that reason, external power supplies are often needed, especially if you're going to have a lot powering off from this board. But for demonstrations, we're going to be looking at the current that is going to be drawn is very limited, so the USB power is sufficient to be used. There's a reset button. Obviously, if something doesn't want to work, sometimes these microcontrollers, you just need to reset them to be able to reboot them and reactivate things. The reset button is essentially just a disconnection of power and then having the power connected again. Okay, let's look at the pins over here at the side. So your IO ref, that's your reference for your input and outputs. You've got your reset pin. Sometimes these need to be activated as a high or low depending on the configuration you've got. You've got a 3.3 volt power pin. For some devices it might need 3.3 volts, and you've got a 5 volt power pin for some devices that might need 5 volts. Again, Keep in mind, you would only use these pins if you're going to be using low power systems. So we have got specific components that we're going to be connecting and powering off from these pins, specifically the 5-volt pin, but at the same time it is low power, so it's safe to do it. As soon as you're going to be doing more higher power things, you could blow up your USB port. You've got your ground pins. Obviously you need ground pins for the connection of certain devices, and then you've got a voltage in pin over here as well. So that is this set of headers over here. This is essentially just your voltage supply that you're looking at over there. Then you're looking at your analog input pins. So that is range from A0 to A5. These are specifically pins allocated to be able to get inputs. They would be what's known as analog inputs. So essentially it will be a voltage that will be ranging from 0 to 5 volts that you could input over here. The microcontroller will read it and will be able to pick up what a voltage is actually coming in, and then you can correlate that. Maybe that voltage might be correlated with the temperature. If you got that voltage from a temperature sensor, you might be able to correlate the specific voltage with a specific temperature. So those are the type of things that you look at over there. Then we come to over here to the right hand side. We've got a TX, which is transmit, and RX, which is receive, and these are your serial input and output pins. Something we won't be looking at in this specific video, but it is something that gets used quite often, and this allows us to communicate between this Arduino board and, let's say, a computer, or maybe another Arduino board. You're able to then communicate with that. What has happened is that these connection pins are connected to the USB plug, so this allows us to communicate with the computer via the USB plug already plugged in. Yet often it is that these microcontrollers are not necessarily connected to the computers, and they need to be independent, and that's where you would actually use these serial input and output pins. Okay, then we've got the digital input and output pins. So these pins are able to be input pins, they're able to be output pins. You can indicate it in a code as to what is an input pin or an output pin. So those are quite useful to use. And we've also got over here digital ground, and then analog reference pin. So your analog reference pin is important for these analog inputs over here. In other words, if you're going to be looking at a range of voltage from 0 to 5 volt, the maximum voltage, which would be 5 volt, you will need to connect to that A reference pin, or that analog reference pin. So the microcontroller knows what the maximum limit is compared to ground. So you could even go and have maybe 3 volts that you connect over there, and then have an input that will range from 0 to 3 volts. Something you would notice also with these digital input output pins that we've got over here, there's some of them that's got these squiggly lines next to them, and these squiggly lines refer to PWM, or pulse width modulation, and those are specific pins allocated for output of these pulse width modulations. And so we will be using that as well in this video session. So pulse width modulation, it essentially also a range of 0 to 5 volts. We would actually look in more detail in a couple of slides from here, but it allows you to output a voltage that ranges from 0 to 5 volts, and so we're able to then sort of allocate a specific value from the microcontroller that will correlate to a specific voltage, and then you're able to, let's say, control the brightness of a LED, or control the position of a servo motor or other devices that we'll come across. Okay, so for this specific video session, what I've done is I've taken an Arduino board. This is the Arduino board we've just looked at. We've just turned it around 180 degrees. So the USB plug is now at the bottom. and we've connected different devices to it. So you will see that what I've done is I've got an analog input over here, which is connected to a 10K pot or variable resistor. So over here I'm able to vary the voltage between 0 volts to 5 volts as an input to this specific pin. Also then connected to it a servo motor, so you'll see there's a PWM output over here on pin 11. That's connected to a servo motor, and essentially depending on what voltage output over here, the servo motor is going to turn to a specific position. And we'll have a look at the demonstration of what a servo motor is. It is essentially able to control the rotation of this motor. That this specific one might be only 180 degrees of motion, and these are often found inside your remote control airplanes. They might be found in terms of maybe devices around the house to maybe move the louvers of the windows. So depending on the time of day or how much sunlight there is outside, you could use it to control the louver positions, and so at night you can close the louver positions completely, but during the day you might want to open them up. So servo motors are able to control that type of feature. You would also see that I've got over here pin 10, which is connected via a resistor to a green LED. Now these LEDs or light emitting diodes are able to operate on a specific voltage, and depending on the color, the voltage range actually varies. So you can some of them need to operate on at least 0.7 volts, some of them need to operate on 1 volt, some of them need to operate on 2 volts, and so obviously if we've got 5 volts connected directly to these LEDs, they will blow. So we need to have some resistance over here to dissipate some power. So if we've got a 5 volt output over here, then it won't blow these LEDs. Okay, so pin 7, that is just a normal output pin that we've used to the red LED. So that will just allow the red LED to switch on or off. And then what I've done is on pin 4, I've got an input pin. So this is going to a push button up to 5 volts. So if this push button gets activated, 5 volts will come into it, and it will be an input to this specific pin. What I have done though is, and it might look a bit confusing, is I've added a toggle switch over here with the resistor. Now this resistor, if this toggle switch was closed completely, it would act as a pull down resistor. So in other words, if there was any capacitance or voltage over here while this push button should be open, this resistor would then drain that and go to ground and dissipate any charge that might be on a specific pin. So essentially what I'm going to try and demonstrate over here is with this toggle switch activated or deactivated, how this pull down resistor actually affects the input to that specific pin. Okay, so essentially that circuit diagram we've just looked at. This is a diagram that's been drawn about that, well, to do with the layout that we will be looking at soon. So essentially we've got the Arduino board over here. It is located with the USB connection over there. I've got a servo motor over here, which is located above the Arduino board. So that's why these specific ports are seeming to be covered, but it's just from a top view. This is the wire connections that I've looked at. You'll see your servo motor has got a positive line and a ground line connected to it, so that powers it, and then you've got this PWM signal going to it, which is this yellow wire to control it. You've got the two resistors going to the two LEDs that I've mentioned over here, going to the ground line on the breadboard. Then I've got also the push button. As I indicated, that's connected to the 5 volt over there. That's going to this input pin on pin 4. At the same time, I've got a toggle switch that is going connected to that specific pin 4, going through to a resistor to ground. Now then over here, I'm joining these power lines for the positive and ground connections together so that I can have the power on this side as well. And you'll see that I've actually taken the 5 volts and the ground connections over here and connected them to these rails. So I've got power then to these 2 rails as well as to these 2 rails over here. Then over here I've got the pot or the variable resistor, and you'll see that the one connection I've connected to the positive line, the other connection I've connected to the negative line, and in the middle one, which will give you the varying voltage, is then connected to this A0 analog input pin. So that is essentially the circuit diagram that we've just seen over here. It's been implemented in terms of a wire configuration over here, and of what you will see in a box when we have a look at that. Just to go over the pulse width modulation, or PWM. So essentially you've got a certain period which is known as a duty cycle, and this duty cycle is being generated on a PWM output pins all the time. The thing is though, is how much voltage is it as a positive, as shown in these examples. So the maximum voltage that's always appearing on the output of the PWM would be pulses of 5 volts. So that would be indication of 5 volts over there, or we've got 0 volts over here. Now if you've got a very small pulse that's been generated for every duty cycle, then that would mean that if we had to take the average voltage over here, it would be very low, probably like a 0%, or very close to a 0% value over here. If we go and we increase these pulses for a longer time period for every duty cycle, and we take the average of this, you'll probably find that you would have about a 25% voltage over here. So if you compare that in terms of voltage, 5 volts being 100%, 2.5 volts is to be 50%, so 25% would be roughly 1.25 volts, which will be the average voltage that you would measure over here. So these pulses, you could actually filter them through a low pass filter, which will then give you the average voltage of, that we are looking for at over here. And then again, very simplistically put over here, so that for you to have a better understanding, is that if we have these pulses that are 100%, so it's going all the way through, pulsing down over here for every period or duty cycle for a very small time period, and then going over across, we'll have 100% duty cycle. And so if there's a 5 volts over here, if we look at the average of the voltage over here, it would be 5 volts. So depending on what percentage essentially we want to have these duty cycles to be activated, we're able to control the average voltage that we're able to get out of those pulse width modulation pins. Okay, so we will see how these pulse width modulation pins influences the voltage output to the servo motor as well as to the LEDs. And then, and essentially this is the theory behind it as to how it operates. Okay, so let's have a look at the actual box that we'll be looking at, and see how it correlates with this specific diagram that we've looked at.
Okay, so this is the box that I've showed you the diagram of, and essentially it is, we've got over here the push button, we've got over here the toggle switch. Over here is a servo motor, which has got this arm that's able to rotate, and we'll see how that rotates. We've got over here the variable resistor, or the pot, and all the connections of the wires are connected as I showed you in that diagram. We've got also the green LED over there and the red LED over there. This is our Arduino board, You will see that there's a whole bunch of electronic components placed over here that are there that we don't have to solder them on ourselves, like the voltage regulators, the crystals, which is the crystal is the heartbeat of this microcontroller. So every time what happens, these crystals generate like pulses, and every time a pulse happens, an instruction would be executed. So this is the basic layout. As I mentioned before, it is a very vague demonstration that I'm going to be doing over here. And the main reason is just to get you introduced into the microcontrollers, see how they operate, and what the different tasks are that you can do with it.
Back in the day when CH was started, it was just a programming platform. It allowed you to program things, and I was in touch with the developers at that stage and told them how we needed to be able to program microcontrollers, what were the needs and stuff. And so over the years, there has been some development with the CH platform, and it's specifically also with the Science, Technology, Engineering, and Mathematics education system, which has allowed for this to happen. So people have put a lot of effort into this to try and develop a system that would be useful. And so there's an application called C-STEM Studio, and this has got all the different things that you can do with it. Like you can, for example, the Robo Blocky, you can use to program robots, specifically like your Lego Mindstorm robots and stuff. You've got your LinkBot Labs, which can be integrated with CH. You've got the Mindstorm controller, so you're able to control Lego Mindstorm components like the EV3 using CH as well. So it's got some tutorial system that you can then use to make certain things work. There's a RoboSim, so you can have a robot over there and have some simulation aspect to it in terms of a virtual robot or a hardware robot. Then you've got the CH Raspberry Pi, so you can program a Raspberry Pi as well using CH. And then you've got CH Arduino, which we're going to be looking at, which allows you to program the Arduino boards. So essentially we're going to, like I said, we're going to look at CH Arduino, and we click on launch to start the application. So once we've clicked on launch, you would see that this is an essential breakdown of the different pins. So we've got like our analog pins for inputs over here. We've got our different digital outputs that are shown over here. And essentially, it allows us to indicate what should be an input on output. So if you click on analog over there, it will tell you that there's, which of these pins are analog pins. As a matter of fact, you might want to also, it was able to identify that this Arduino board is connected to COM port 3. I can connect to it over there via the USB. It's connected. And over here you'll see that the analog pins are showing what voltages are appearing as input pins over here. So if we had to look specifically at this A0 pin, I've got at the moment that variable resistor connected to it, and I'm just going to turn it, and we're going to see what happens there. So as I turn it, you'll see that the values are changing, the voltages are changing. So a voltage of 0 correlates to an analog input of 0, and I can keep on increasing that, and let's see what is going to happen when we get to a voltage of 5 volts. So at 5 volts, or shown over here as 5.01 volts, we get a maximum value of 1023. So essentially your analog input is a 10-bit input. In other words, it's 2 to the power of 10, which is 1024. Obviously, 0 being your first value that you're going to be using, the maximum value becomes 2 to the power of 10 minus 1, which is 1023. So 1023 is your maximum value that you can have for analog input. And we will see as we go and monitor these, and change these values. So you could essentially with these changes, you'll see how the output changes as well. So remember, keep in mind to correlate 1023 with 5 volts, we're actually able to sort of say, well, what value would you have to then take into account to correlate with these values. I mean, if you've got a voltage coming out of a temperature sensor, which is at, let's say, 3 volts, it will be 3 divided by 5 volts multiplied by 1023, and that will give you an indication of what analog input you're probably getting over there. Again, if you're reading the analog input, you might say, okay, well, I'm getting an analog input of, let's say, 800. What voltage would that correlate to? Was 800 divided by 1023 multiplied by 5 volts, and that will give you a voltage that you're able to then use. So you might have a data sheet, your temperature sensor might say, well, a certain voltage is going to correlate to a certain temperature. There might be some equation involved, and you're able to correlate this using a simple equation like that. Okay, and then you're able to indicate over here the digital pins as being inputs or outputs or PWM output pins. You can do it manually over here, yet we would actually do it in the code, as you'll see soon. So I must mention over here that what is going to happen with the code that we're doing, that we're going to be doing in this specific session, is going to be looking at the Arduino library. Which is essentially the same library that's been used when you program the Arduino board. So, or the Arduino software that you might have seen coming with Arduino boards. Now, my personal opinion is I don't like the Arduino software as it becomes available. The Arduino software and also the commands and libraries that we're going to be using for this specific session, it's useful for introductory level, it's useful for school level programming maybe. As soon as you get to a more advanced type of systems, then it becomes problematic. And the reason being is that these libraries are set in such a way that they're not always using the actual features of the microcontrollers. So, for example, microcontrollers are able to generate pulse width modulation outputs while other code is being run. Yet with what we found with these specific Arduino boards is that those libraries don't allow you to do that, and this causes a lot of delays and certain things not to always work. I often have it with students that they come and ask me, why is this not working? And they don't understand why maybe two motors can be controlled at the same time, which might use two different PWM output pins. And my first question would be, whenever they come and ask me this, are you using Arduino software? And the answer is 99% of the time, yes, we are. And I'm like, okay, that's where your problem is. You need to look at some other software platform. So I mentioned over here, this is what we are going to be looking at, just to get you introduced into the system, see how the inputs and outputs can be used. But please keep in mind, this is for your very basic type of programming tools that you might want to do. You want to switch on the light, you might want to control a servo motor, but anything more advanced, you might want to start looking into other software packages. For example, Code Vision AVR, or CVAVR, which is a short version for Code Vision AVR. A nice package. It's a little bit more advanced in the programming, but it allows for things to run in the background of the microcontroller, and so that other code can also run in the forefront should you need to. For example, let's say you might have a situation where you're trying to run some code, and the Arduino software or libraries will let that code run, but it might not allow you to have external interrupts to be activated during that time, or inputs from external pins to be monitored during that time. And one of those pins might be an emergency shutdown button that might need to be pressed to stop everything from happening. And so the issue is that if we don't have these things running in the background, it can also have a safety aspect related to it. So we will look at that in detail in a different session. Again, over here is a good view of the board with all the electronics that's connected to it. And keep in mind that these microcontrollers, even though they are very small, they might not be very powerful, but they are the very basic of a computer. The rockets that were launched to the moon for the moon landings and things like that had processing powers that are much less than these microcontrollers. So these microcontrollers are quite powerful in comparison to previous technology, but they're still very limited. They've got limited memory, they've got and that could be in terms of your RAM, it could be in terms of flash memory, in terms of the code that you're going to be putting onto the microcontroller. So we do have these limitations that we are restricted to, and that's the reason why you often look at minimizing your code as much as possible so that you don't run out of memory. These are also usually 8-bit microcontrollers, so you've got a memory space that's 8-bit. So you can't necessarily have too large numbers that you're working with, and you've got to accommodate it. And you'll see these things coming out as you program with microcontrollers, as you do different tests, as you try and debug things. You'll see that there's these limitations, and you can't understand why it's not working. And then when you start taking that into account, you have to look at other ways to approach these problems and to solve it. So these microcontrollers, they are quite powerful when compared to, let's say, the rockets that went to the moon or so, but at the same time also very limited compared to maybe your desktop computer or your laptop computer. So just keep that always in mind. Alright, so while this is always connected, we've got a green light over there. We will then go across to CH platform or CHIDE platform. We will use that to program it. So essentially, whatever you program on CH, it will send it to the microcontroller, and you have this two-way communication happening in real time, which is useful, but like I say, you can't always have a computer connected to the microcontroller. So sometimes the microcontrollers have to be independent, and you need to use your TX and RX of your UART, which is your serial communication pins, to communicate with other devices. So just for introductory purposes, we're going to be looking at the very basics and a very brief overview of the inputs and outputs. So once we connected, we can then move across to CH and look at how to program the device. Right, so now that we've looked at all the electronics, we've looked at how everything is connected, we've looked at how to get connected between the computer and Arduino board, we've got to now look at the programming. Now at this stage, I'm assuming that you know how to do your normal programming in C. If you do not know how to do programming in C or in CH, my advice is to look at the series of videos regarding programming in C. I will put the link in at the bottom of this video, and then you can get familiar with that, see how you're able to do your basic programming, see how you would be plotting graphs, and I will be assuming you've got that knowledge to be able to continue with the programming of these microcontrollers. In saying that, most of the things that we're going to be looking at is sort of quite new and very specific to microcontrollers, but it will be considered that that type of knowledge that you've done in that programming, or that I've done in those programming videos, would be also used for programming of microcontrollers. As a matter of fact, that series of videos that I've done focuses a lot of things in terms of taking memory into account, taking into account different ways to pursue things in a very similar fashion as you would do for microcontrollers. So even though in this series of videos we might not actually cover all those commands that we discussed over there, you would see that you would use those commands in future projects that you might be doing. Okay, so this is our basic layout of our of programming in CH. Like we've mentioned before, you've got your libraries introduced in the beginning over there. We've got int main void, we've got return 0, and we've got our main program over there. When it comes to programming of Arduino boards, there are a few things we need to include, a few commands that you've got to be familiar with. So I'm just going to be going through those commands now. give you a brief explanation of what they're for, and then as we go through examples, you'll see how they get used and how they get used in the different applications as such. Okay, so the first thing we've got to look at, because it's Arduino board, we're looking at a new set of commands, we've got to include a library for the Arduino. So this is your Arduino board library that's going to be included over here. So hash include arduino.h. Okay, so that's one new thing that we've got to keep in mind that we've got to include. Okay, then we get to the main program. Now remember I mentioned to you that you've got your digital pins that could be inputs or outputs. So those would be either a 1 or a 0, or a high or a low, or 5 volts or 0 volts that you'll be outputting over there. So all of those terms correlate with each other respectively in terms of high or low, or 5 volts or 0 volts. Okay, so because these pins can be input pins or output pins, we need to actually indicate it to the program. What are they? I mean, are we going to be connecting a push button on a specific pin, but at the same time we do not want to go and then have an output voltage on that pin as well. If we do that, you could find that while a person is pushing a button, it's outputting let's say a 0 volt, and it's causing a direct short, so you could blow your microcontroller. So we need to indicate to the microcontroller which pins are inputs and which pins are outputs. So to do that, we use the command pin mode. Again, look at the lowercase and uppercase of the letters, very important. I can just maybe show it to you. If this was lowercase, it wouldn't have gone into a purple color. So we need to have that in a specific order. And we looked at pin 7 being an output pin. That was on the diagrams that we just looked at with our configuration of the Arduino board connected to the other electronics. Okay, so we've got that, and then we also had to look at pin 4, which was an input. Again, uppercase and lowercase is very critical over here for the output and input statements. Okay, so over here we've declared that pin 7 is now output pin. We've declared that pin 4 is an input pin. So this is like declaring your variables as you would do in a normal program. So now that we've done that, the microcontroller and the program knows what's inputs and what's outputs. Okay, now if we can get to our after we've done that, what you would generally have, because a microcontroller is needing to execute commands so quickly, you would probably find that it's something that you would not be able to see happening just because in terms of how fast things are happening. So with the set of commands that we might be typing out might be executed in 1 millisecond. And if you have that 1 millisecond light must flash, your eyes won't be able to pick that up. So what you want to do is you want to keep on repeating these commands over and over, and let keep on running through the microcontroller so that it keeps on checking for inputs and putting out outputs and stuff. The issue is that when it comes to this specific aspect, sometimes these type of things, this looping or repetition that you need to do might not be required thing to look at using your Arduino boards, but it is something that would have to be taken into account. Okay, so if you want this repetition to happen, you need it to happen infinity amount of times, and for that we're going to have a while loop 1. Okay, so essentially what this is saying is while 1 is 1, which is always going to be true, it's going to keep on repeating this loop. So this loop will run infinity amount of times. So that's the first thing we just need to keep in mind. And in this piece of code that we underneath this loop, we will have all our commands that have to be in terms of checking if an input is activated in terms of outputting a voltage to a certain pin or so. This is what we're going to be then having all this type of code in this specific while loop. Okay, so if you want to check if a pin is high, for example, you can use the if statement. So you should be familiar with the if statement. And what we're going to say is digital read. So we're reading the digital input, and it must be of pin 4. So obviously we know pin 4 is an input over there. So of that, and if that is equal to high, then, and again, if you look over here, this is our condition we're looking at, then a certain output needs to be done, or a certain task or set of commands need to be done. So that's if you want to check if a pin is high. Again, we can also go and check if it's low. So maybe there it is that the button is not pushed. So that would be shown in that type of fashion. So if the digital read of pin 4 is equal to a low, then execute a certain number of commands. Okay, what happens if you want to output a voltage to a specific pin, 5 volts to a specific pin? So it's either high or low. For that we use a command digital write. Okay, and that would be, we know the pin 7 is our output, we've indicated that over there, and that needs to be a high. Okay, so we're writing to pin 7 a high value. So in other words, there'll be a 5 volts appearing over there. It would be a logic 1 that would be outputted over there. We could also go and say, in a specific example, make the output on pin 7 to be a low. Both of those will be acceptable commands. Okay, so that's in terms of the digital inputs and outputs. So that's pretty straightforward. It's either a 1 or a 0. Now what would happen if you want to read an analog voltage and you want to see what value it is? So it could be you're reading from your analog to digital converter or your A to D converter. You're getting from, let's say, pin A0 a value, and it might be the value 500. How are we going to be able to read that value and find out it's the value 500? Well, before we do that, we actually have to declare an integer. And I'm going to call it VARR, standing for variable resistor, because that's where we have our variable input coming in. And I'm saying that's equal to 0. Okay, so that's declared as an integer. So when it comes to our main program over here, I'm going to then say, or the command to be able to then read from the A to D converter or the analog to digital converter is analog of A0. So we know that A0 is a pin as the input, as we've seen in the circuit diagram. So it's analog read of A0. You'll see it's also now turning into purple. Be careful. This is an American way of writing analog, not the South African or British English way of writing analog. So that would then be the command to read from A0. The thing is, as one thing to read the value from a specific pin, we actually need to save this into some variable. And therefore, I'm going to save it as VARR is equal to that, whatever that value is that I'm reading from that A to D pin. Okay, so that is this is essentially going to read the voltage that's on a specific pin. It's going to correlate it to a value that's between 0 and 1023, and that value will be then stored in the VARR or variable resistor variable. Okay, now lastly, in terms of our inputs and outputs, we might want to output an analog value. So on pin 11, for example, I've got for this specific case, I've got an analog output or PWM output that I've got connected to that. That's connected specifically to the servo motor. Okay, so I want to then, whatever value is that I've read from this analog to digital pin, I want to output that to the microcontroller or to the servo motor. Okay, so at least as an analog output. So to do that, I'm going to say analog write, which is pin 11, and it's going to be a value of VAR. Okay, so this is a command that you'll output a PWM signal of a specific value, again varying from, in this case, from 0 to 1024. But the problem that we find over here is that when you've got the output of your PWM, it's usually in 8-bit number. So the maximum number is 255. And we'll actually see how that affects our system when we look at it now. But this is the way that you would output your PWM signal. It will be an analog output that you write to a specific pin, and you'll give it some value. We could go and give this value, make this value, let's say 200, and it will correlate 200 out of 255. It will make 200 that correlation, put into a voltage, and that specific voltage will be then on that PWM output pin, specifically pin 11. Okay, so we are able to do that. That is one way of doing it. Again, we will look at this when you start looking at examples in greater detail of how it affects things. Okay, so before we start looking at the examples, there are two more commands that we need to, or three more statements that we need to look at, and that is specifically to do with the servo motor. So remember when we had to do plots, we had to have declare what plot is as a chplot command or variable, and very much the same thing we're going to be doing with the servo motors. So in the beginning over here, after you've declared your pin numbers, we need to say servo.myservo. Okay. Essentially what we're doing over here is whenever we are referring to my servo, it's going to actually then be referring to this specific servo, or indicate it as a servo that we've connected to that specific variable. So we will be using that over there. Then we need to also indicate where the servo is attached. So I will say my servo dot attach is on pin 11. Okay, so if we have a servo motor, we need to include that over here. You know, as a matter of fact, just to simplify things, maybe I'm going to just make a small change over here in the scope. Pin 11, I'm saying here is the analog output pin, but I mean the servo motor is connected to it in theory. So let's just change this to a 10. So whenever I output the analog value, it's going to go to pin 10, and so that PWM voltage will go to that. Not to confuse it with the pin 11, which is attached to the servo. Okay, and then lastly, if you want to now go and actually output this this specific value to the servo, instead of saying analog write, we will use a command that is my servo dot write, and that would be the variable that we would indicate over there. So let's just see what let's just see what commands we've covered over here and the structure, and for how it compares to your other programs that you've been exposed to. So firstly, it's the Arduino library that we need to include. That's important. Then we need to declare which pins are inputs or outputs, and that's done with the pin mode command. We need to also keep in mind that the servo needs to be indicated. We're giving the servo a name called myServo, and we are saying which pin it's attached to. So once we've got this up over here, this is our setup of the minimum of what is connected to what's inputs, what's outputs, and that's always in the beginning of your main program. Okay, then we get to our while one, and this keeps on looping and repeating the code that's below here so that we can keep on checking for inputs and outputs respectively. We looked at digital read, so we can look if a digital read on pin 4 is low or high, and we've placed it into an if statement. And depending on the output over there with this comparison, keep in mind comparison is a double equal sign over here, we are able to write a digital value to a pin. So in this case it's pin 7, and it's either low or high. We can read from an analog to digital pin or A to D pin with the analog read in brackets A0 to A5, depending on which one we connect it to, and we're storing this into variable VARR. We're able to output a PWM signal with the analog write command, indicating it's pin number 10 that this is going to be writing out to. We know that pin 10 is a PWM pin because if we look at the board of our Arduino, we will see that next to the pin 10 is a little squiggly line which appears like that, and that indicates it's a PWM output pin. So pin 10, comma, and we're able to write some value to it. In this case, it's a value that's between 0 and 255. So I've just put 200 over here for now, and we'll see what happens if the value should be higher than that. And then lastly, we're able to write to a server a PWM value, and that's done with myServo.write, and in whatever value it is. So over here again, we can indicate to be, let's say, 150, and it will go 150 out of that 255. So with a servo motor, if it's got to do with angle, let's say it's on an 80-degree angle servo motor, you could probably find it will go 150 divided by 255, which is your upper limit of your PWM, and multiply that by an angle of 180 degrees, and that ratio will then correlate to the angle on the servo motor. Okay, so these are the basic commands we're going to be looking at, other than the ones that I've already mentioned that are in your programming or CH video series. But these are the additional ones we're going to be looking at, and we're going to see how we can use them, how we can control the microcontroller, and later on we'll be looking at how to plot graphs as well with the information that we receive.